Hello, I'm Suzanne Salee, Instructional Technology Specialist for the Creighton School District in Phoenix. It is my pleasure to introduce you to the K-12 Arizona Computer Science Standards through this series of videos. These videos will help you understand the foundations of computer science, the importance of computer science for all students, and how computer science can be integrated into all content areas. This video is part of a 3-video series. Video Series 1, Introduction to the Arizona Computer Science Standards, will explore what is computer science, reading the computer science standards, and the computer science practices. Video Series 2 will examine each of the 5 essential concepts the computer science standards cover in detail. Video Series 3 will explore integration of computer science into other subject areas such as ELA, math, science, and art. At the end of Video 1, you will be aware of the process for developing the Arizona Computer Science Standards, understand the foundations of computer science and computational thinking, identify different skills developed through computer science, recognize the importance of developing computer science skills for all students, and be able to identify different methods for teaching computer science. The Arizona Computer Science Standards were developed by working groups of educators representing 41 Arizona districts, 8 Arizona counties, and several interagency colleagues from career and technical education. These groups of teachers met together in multiple sessions to work on researching and developing the Arizona Computer Science Standards. As these groups worked, they kept these concepts in mind. The Department of Education develops and adopts standards that determine what a student should know, but the how is left to schools and districts to decide. Standards determine what students should know and be able to do by the end of each grade. Curriculum and instruction make up the how. Curriculum can include things such as curriculum maps, scope and sequence, and pacing guides, along with curricular resources such as textbooks and digital resources. Instruction centers around instructional strategies and best practices and is where the real art of teaching lies. The Arizona Computer Science Standards were developed using guidelines from the 2016 K-12 Computer Science Framework, the revised 2017 K-12 Computer Science Standards from the Computer Science Teachers Association, and computer science standards from several other states across the country. The computer science standards are comprised of 5 essential concepts supported by subconcepts. Concepts are categories that represent major content areas in the field of computer science. The 5 essential concepts for computer science are computing systems, networking and the internet, data and analysis, algorithms and programming, and the impacts of computing. They represent specific areas of disciplinary importance rather than abstract general ideas. Each essential concept is supported by various subconcepts that represent specific ideas within each concept. In addition to essential concepts and subconcepts, the computer science standards are also connected to computer science practices, similar to math and science practices. These will be discussed in more detail in videos 2 and 3. Computer science is more than just coding. Computer science helps students become computationally literate creators. According to Code.org, computer science develops students' computational, problem-solving, and critical thinking skills and shows them how to create, not simply use, new technologies. This fundamental knowledge is needed to prepare students for their futures, regardless of their ultimate field of study or occupation. Computer science is foundational. It is a core discipline. We live in a digitized, computerized, programmable world, and to make sense of it, our students need to understand computer science. Practical computer science skills can help students learn and create and bring more relevance to nearly any subject, from history to literature to current events to science. And every student should have an opportunity to create something that could change the world. Computer science is more than just coding robots or making characters move across a screen. Students learning computer science begin to develop skills that will allow them to succeed in our rapidly changing world. Ways of thinking, questioning, and working together. Skills many employers are looking for. What is computational thinking? Generally, computational thinking is the process of breaking down a problem into simple steps that a computer could understand. It is the thought processes involved in expressing solutions as computational steps or algorithms to complete a task. Simply said, computational thinking is taking big problems, breaking them down into smaller problems, and solving them. Computational thinking and computer science isn't entirely about computers. It's all about people. While we write programs for computers, we are really writing programs for people to help them communicate, find information, and solve problems. My students have been using technology for a long time. Isn't computer science the same thing? Computer science is sometimes confused with other areas of technology. Take a look at this table. Computer science builds on the concepts of computer literacy, educational technology, digital citizenship, and information technology, but it is not the same. The first four concepts focus on using computer technologies as opposed to understanding how and why they work and how to create those technologies. But I'm not a computer scientist. You don't have to be a mathematician to teach math or a writer to teach writing. You don't need to be a technology professional or a computer coder to implement these standards. All the new terminology may seem daunting, but don't let it get the better of you. For example, algorithms is one of those computer science sounding words. It is simply a step-by-step process to complete a task, a list of instructions. We use algorithms in math to solve problems. There are lots of resources and opportunities for teachers to develop their computer science understanding and skills. Online tools, online courses, videos, and much more through places such as code.org, Google, Microsoft, and many more. But don't be afraid to learn right along with your students. Computer science can be taught if you have access to digital devices and even if you don't. Plugged lessons require students to have access to devices such as laptops, Chromebooks, iPads, and tablets. Plugged lessons may include block-based coding platforms such as Scratch or Codable to help students learn computer science concepts. Unplugged lessons do not require students to have access to devices. Students can learn and apply computer science concepts through physical and kinesthetic experiences. Unplugged lessons can be taught independent of computers through games and puzzles using string, paper, cards, or even running around. Thanks for watching today's video. What is computer science? Be sure to check out video 2 in this series, Reading the Computer Science Standards.